So good morning, everyone. Welcome to the Sunday session. We'll continue exploring digit TP. Today, we are going to focus more on problems since we covered the theory last time. So let me try to share my screen. Okay. All right. So you guys can see my screen, right?
Yeah, we can see.
Great, great. So a couple of things. We'll go really fast. So last time I totally missed a session by Sasank and DP, which was on graph. So sorry to forget that, but yeah, go check that out. I hope I haven't forgotten any other thing, but remind me if I have missed it, then I'm really sorry about it. Then I will just go through whatever we covered last time. I will give you a 5-minute overview in case you have forgotten or what was the final conclusion, and then we will start solving a couple of problems. We'll try as many as possible. Uh,
This graph session is the one where the shortest path algos were covered, right?
yes, I think there were two sessions, so uh, the Sank may know more.
Yeah, one on Bellman Ford and another Dice.
So I have to mute. If you are not speaking, please mute yourself. Okay. So, okay, what we covered last time, actually, we went through one example where we had this thing, find the sum of numbers between a range or something like that. So you had some range from maybe 220 to 5 up to 558, something like this, suppose. Then what we had covered that we can look at the previous video if you are not very sure how we demonstrated that, but we found we can get all these positions for the number indices, then where the restriction is applied or not, and then what was it? And then sum, we were passing sum. So using that three parameters, at least that was my implementation, how I did it. We calculated the sum in this range. So also, just to give you a little idea, so suppose the range was 10 to the power 18, for example, that could be the range for the number. Then your time complexity in worst case, think about it. So position could go up to 18 digits, right? So your position can go up to 18 digits. Your restricted value can go up to 2, and then some can go something like, if all the digits are 9, then 18 into 9. So you can just calculate what is the time complexity. If you want to know in terms of n actually, so what is 18? 18 is nothing but log 10 base n. 2 is fixed, and then 9 is the max, but you again have 18, so this is 9 into log 10n. So if you just multiply all of these, it becomes 18 into log square n, and I'm talking about 10 base. So this is not big number. It's a very, if you try to draw it, you can go to Wolfram Alpha or somewhere, you can try to draw it. For a very big number n, you will have a pretty good time complexity. So the problem could be like sometimes this constant factor, but that depends from problem to problem. If this constant factor doesn't trip you, then most of the time this would be okay. So that is what we did, and I will just give a quick pictorial overview of this state, and then we will actually start jumping to the problem. So for example, the way we were doing, how it was working, suppose it's a 4-digit number. I first selected 0, then I selected, for example, 6, and then I have many things here. And then I have many things here, like, for all of these, because I'm saying just 4-digit number. So this is first digit, this is second digit, third digit, and fourth digit. So suppose I got a, like, answer here. While my sum, because see, when I'm going down, I am passing my sum down the, like, call chain. So at this point of time, like, at this point of state, like my current state is value of sum is actually 6, position is 2, and suppose restricted was 0. So that was my, state. If I go to, for example, 1 and then 5, I select 5, and then I have the same kind of call stack, same kind of recursion tree, below this, below this, below this. See, the state would be similar because 1 plus 5 is my sum. So I don't know.
Roger,
Yeah.
this what you are solving is count number of ones in the range, or
No,
uh, okay.
we are going over the sum in a range. So if you look
How
at this,
how many digits sum up to the target sum?
yeah.
Okay.
So yeah, I'm just reviewing what we did. So this is how it is working in my approach or the code I did show. So I hope if you have seen the previous session, you would recognize this thing. Let me see if I can erase. I don't know what is this thing here. Oh, can you guys also see something here? Like some
Yeah,
marking? I
let's,
don't know.
let's share. Yeah.
I have no idea. Oh, it is staying also. So I don't know how to get rid of this. Interesting.
Try undo.
Uh,
So the reverse arrow below home,
reverse. Okay.
it went.
Thank you. Yeah. Something happened. I didn't even know. All right, guys. So with that, we will actually start going to the problems. I hope you understand how it is working. If you need more, like, detail, I would suggest go and draw the recursion tree yourself. Just remember that this is a 3-dimensional state. So when I am showing you one of this, one of like this value, it is not just one. It's not just one value. Think about there is a like 3-dimensional space. So then you will recognize why, like, representing as a 3 value will explain what is going on. All right. So enough of that, and I think we can start with the problems today. Since we started some problem last time, I think we should start with the same problem. So that is done. So I will just remove the problems which were done. We will come to this. We had started this problem, which is called almost everywhere 0. We briefly started working on that, and then we will work on it now. So almost everywhere 0 means like most of the time you will have zeros. Only few of them will be non-zero digit. So that's the problem. Find the number of integers between 1 to n, inclusive, means n is also inclusive, that contains exactly k non-zero digits when written in base 10. And see, the range of n is 10 to the power 100. Okay. And k equal to 3. So for example, n is 100 and you just want one non-zero digit, then how many such numbers you can make is 1 to 9 is good. Then all the 2 digits which have zeros, because we can only fill one place with like non-zero digit, and then the only 3 digit will be 100. And of course the since we want to put zeros, most of the time you will put the non-zero digits in the beginning, like in this, especially in this case. Okay,
Roger,
yeah.
sorry to interrupt you, but quick question. Are we going to cover the count one, number of ones in the range?
Oh yeah,
Uh,
yeah.
okay.
So since I started this, what I am thinking, I will go to this. After that, I will solve couple of problems from LeetCode, like 3 or 4. Again, I will come back. We will go back and forth.
Okay. Okay.
Yeah. Unless you guys only want LeetCode problems, that is fine too.
Actually, lead code
Yeah.
is little bit easy for us to check, right? That's the only thing.
Yeah. I mean, after this problem, I will go and cover 4 problems for LeetCode for sure. That is how I had thought. I'm doing it because we had already started, right?
Yeah. Please then go ahead with your plan. Okay, no problem. Thank you.
Yeah. So let's, okay, so what is the problem? In this problem, as you saw, that we have a range, right? Again, we will have 1 to n, right? So 1 to n. N can go up to 10 to the power, I think 100. And they said like k digits could be, so if I have these digits, the rule, suppose I'm building this number, the rule is that this number which I'm forming using this process we just learned, it should have exactly k non-zero digit. Okay. And k's value was also, I think, up to 3. It can't go more than 3. So that is upper bound by 3. So if you think about state, we can continue building the number as we were doing in the previous problem. Uh, and then we will keep counting only this time, which whenever I choose a digit, I will only add it if it was a non-zero. And then I will make sure if if I cross limit k, then I will not include it, right? Because if I include it, I know that it is not going to give me a valid answer. So I can just ignore that. One way is you can keep doing that. You can find the sum and you finally select, hey, is my sum exactly equal to k? That could be another approach. Yeah. So most likely here, as we did in the previous problem, we will have again position. We will have restricted will continue because we are selecting digit every time. And this will be my where we are keeping the count, like how many non-zero digits we have so far. Position will be again how many positions, I think 10 to the power 100, so roughly around 100 I can say. 100 or 101, I don't care that much. We'll see. I will anyway have some padding just to ignore that. To restricted, and count will be like, I know we can have count up to 3, so I just pad it to 5. So if you see your time and space complexity will be pretty good if we just go with this approach. 100 into 2 into 5 should be good. Anybody has any question on this approach or with problem?
Hi, this is Saurabh. What is restricted here?
So Saurav, I think you haven't watched the previous video, right?
Yes, this is the first time I joined.
Yeah. So as I mentioned, uh, if I continue going to that route, because last
Yeah,
video was entirely focused on just that part, understanding that. So
okay, please
it would
continue. I
be
will
not
watch
good
that
for,
video.
yeah, please watch that. And then this will make more sense. So what was your question, by the way? Restricted, what is restricted, right?
Yes, sir.
Yeah, restricted is okay, very fast. Suppose if I am building some numbers 6235. If I choose my first digit as 6, then for the next digit, I have to choose any digit which has to be smaller than equal to 2. Does that make sense? I cannot choose 3, 4, 5 because if I choose that, then I will cross my range, right? But if I select my first digit as 5, then I can select any digit from 0 to 9 for the second position. So what I would say that, hey, this guy has no restriction, but this guy has restriction. I mean, that is the basic, short
Okay.
overview of the concept.
Okay. Thank you.
Yeah, no problem.
Roger, I have one question.
Yeah.
Roger, on what basis you are defining the padding, like how much more size we need to take?
Normally I pad 1 or 2, 2 or 3, just because, just to keep, not worried about whether I missed one digit or not. For example, if it is 10 to the power 3, right? So
Okay.
if my range is 10 to the power 3, then I know it has to be within 1000, 3 digit, right? So I would
Yes.
normally take 4 to 5 digits just to make sure that I'm not
Okay.
missing anything.
Even if Roger, if I take 10 to the power 3 only, so will there be any concern? Because the limit is restricted to 10 to the power 3 only, right? So how will it affect me, right? I was thinking.
So if your range is suppose 0 to 100, right?
Yes,
Suppose
yes.
0 to 100. So you have to make sure that you include 0 also and 100 also. So 101 is the right.
Yeah, exclusive, yeah.
Yeah. So like a lot of people, you will say they will pad by 4 or 5 to ignore this thing. They don't want to think about it while they are solving it because it's not a big change. But
Okay.
yeah, if you spend some time thinking, you can definitely get a better number there.
Okay.
Okay, so
Roger,
yeah.
sorry, quickly, I missed the key part where, so on what basis are we propagating the restriction here again? Sorry if you covered it, I maybe missed that.
I think you this is Jagrat, right? You
Yes,
learned
yes.
last time. You said you understood also.
No, 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 I understood it, but in this case, I was just
Oh yeah, yeah,
the flag logic. Yeah,
sure.
I got the basic approach. Yeah.
Yeah, it's the same thing. What I am doing, since I have been given a range 1 to 9 n, right? I am building my numbers again the same way, right? I am upper bounded by some value n. Just to make sure that I don't cross that, I am just trying to have this restricted value as we had in the previous problem, where we were calculating sum for all the numbers. Same concept, right? Suppose my number range was same thing, 6 to 3, 5 here, right? And I suppose I started with 6. I will start with 0, 1, 2, 3, 4, 5, 6. Up to 5, my restriction for the next digit will be no restriction. But when I select 6, then I will have to apply some restriction, right? So it's exact same logic which we learned last time. So let's look at the code. Hopefully that will give you more idea what is going on.
Yeah, no, that makes sense. But I was wondering
Yeah.
when we say that, how are we accumulating the count? That part I was trying to
Right.
figure.
So in this case, it's not sum, it's count, right? That's right. So how would you accumulate? Like if I select 0, then I would not increase my count, right? Suppose I selected first as my first digit. Okay. And then I selected 0. I will say, hey, no problem. In count is not increasing. 0, no problem. I selected 2. I said, hey, your count was 1 here and you added one more. So now your count will become 2. If my k was 2, then I will have to make sure that further if I add a position, I don't add 0, 1, 2, 3. Like 0 is fine, 1, 2, 3, 4. I don't want to breach this limit which was set, right? Because here the problem is if you are selecting 0, then it is fine. You are not crossing that limit. But as soon as you breach the limit of your k, you have to make sure, I mean, at least in my implementation, I don't want to continue adding all those non-zero digits, that it's worthless. If my limit was 5, and if I am adding 10, 11, 12, 13, I know that that guy will not give me a result. So that's how I would be doing that. So let me show you the code, and then I'm pretty sure you will understand pretty easily. I think last time we were here. And so, okay, same story. We have a position, we have a count, we have a restricted. And this time we are given this thing that, hey, you can only have up to K value. Like your count should not be more than K to give a valid result. So my base case will become that, is my count equal to K when I reach the end of the string? Like, when I reach the end of the, like, all the positions. If it is, then it will give me one valid number, which is satisfying this property, right? So far, so good?
Yes.
Okay. Then this is memoization part. It's not anything different here. Same thing as you saw like last time, limit equal to restricted, which we explained that how I have the limit set there. I get a new restricted value. Here is the important point. If I equal to 0, if I have selected a 0, then I would make sure that I don't increase the count, because whatever count was earlier, if I add a 0, like whatever was value for 100, if I add another 0, 1000 has also just one non-zero digit. 10,000 will also have one non-zero digit. So I will not increase this count. But if that is not the case, and I am selecting a digit now, which is non-zero, then I will only pass it if the count is less than K. I mean, that is my optimization basically. What I am saying, that in that case, increase the count by +1.
Yeah, that makes sense. See, that's the part so in this case, we have the restriction on I equal to 0. And in the earlier one for the, we were restricting when we were selecting, I think, the top of the line digit.
Yeah.
Like, right? Then I have to, because if I selected, yeah, something like that. It was not based on I equal to 0. There was some other condition.
Right. Yeah. That's what, like, in most of the problem, this condition and this kind of conditions will change slightly. So you have to make certain changes based on that. Other than that, you can see it's pretty much similar, right? You will start it like this. Okay, start with 0 position, 0 count, start with a restriction, and then whatever K was passed, I just passed as a parameter, and then you will just return the result. So anybody has any question, or we will go to the LeetCode problems now, like 3 or 4 problems we'll do from LeetCode. I think everybody is good.
I have a doubt.
Yeah.
So you are actually restricting the K to be less than count, right? Where in the else condition. Like you are making sure the count has to be less than K, only then you will be calling the function.
Yeah.
Yeah, in such case, why are we looking for, why are we checking the condition whether the count is double equal to K at the end of the string?
See, when you are here, suppose your K was 3. You found one new value. As long as count is less than 2, you would like to increase the count, right?
Okay. Yeah.
Then when you reach here, it will be 3 already, right?
Yeah.
Yeah, because if it was already 3, for example, then you will make it 4 in this loop.
Yeah, but then you will not even call this, right? Because count to be less than K. Okay.
Yeah, I'm not even calling, right?
Yeah, you will be not even calling.
Yeah.
So you can just return 1, I guess then.
Oh, you are saying just return from here. Yeah, you can return from here, or you can, this guy will anyway return eventually. right?
I mean, if the position is equal to the string length, there you can just return 1, I guess, then maybe.
Oh, you are saying, but in future you can also get, right? If there is,
Okay, okay. I got it. I got it.
yeah,
Roger, I had one doubt.
I get it.
yeah.
When restricted is equals to 1, why are we taking limit as the current character?
So restricted equal to 1 means that whether this value is restricted or not,
Yeah.
if it is restricted, that exactly means that, okay, I have selected 6, for example.
Okay.
Then for the next position, what is the range for my, like, that I can go from? It can go only from 0, 1, 2, right?
Yes.
Okay. Okay, I got it. If we choose the bigger one, then it will become greater than. Okay, I got it.
Yeah, it's the same thing which we learned last time,
Yeah, got it.
right? All right. So with that, let's close this. I think you guys are okay with this. It's not very complex. So, and also all these code will be eventually I will share that, so you can go debug, make some changes. Like you can write your own main program and just refactor this code.
Okay,
So,
Roger, one more thing.
yeah.
Actually, I think it will be really good if we also see the way of coding it in the bottom of session for a couple of problems.
So I haven't done that, and that's why I explained that this is how I am going from top to down, right?
Okay.
Yeah,
Okay.
that was I covered in the first 5 minutes. This is how I have done. But yeah,
Okay.
somebody can try that and share on the Discord channel. Actually, there is
Okay.
a Code Forces a blog for that also, for that approach. So
Okay. Please share that later. Yeah.
yeah, sure. Okay, with that, let's go
On
to
Roger, on this ad coder platform, can we
actually
actually submit it?
yeah. Yeah, you can submit it. Yeah, you can.
Okay.
There are so many platforms. Actually, somebody showed me 2 more questions on LeetCode. If I knew that there are that many LeetCode problems, I may not have chosen AtCoder. But they have sometimes very good questions also. Okay, so let's go to this problem. I have mentioned this problem on Discord, and I also shared a possible solution. So try to understand what is that problem. Given an integer n, count the total number of digit 1 appearing in all non-negative integers less than or equal to n. So for example, you're given 13. So where all you can see digit 1 appearing. So 1, and then up to 9 you won't see anyone appearing, and then 10, 11, 12, 13. So why it is oh, actually, okay, here it's 2 times. So that's why there are 6, that the output is 6 here.
Okay.
So that's the problem. Anybody wants to talk about it? Or so what you are given is again same thing. Like let me just write here. It will start to look very similar after some time. So you are given 1 to n, right? 1 to n. So you have all these positions. These are all your numbers. When you generate in your tree, these are eventually all the numbers you are generating. And what it should, which property it should satisfy is that number of digit 1, it should contain number of digit 1, right? That was the problem, I think. It should contain digit 1, I guess.
Yes. That's
Yeah. So how many number of digit 1 it has? Because you, for 11, we saw that we will have value as 2. So what I'm saying, I will keep a count of digit 1 in this number. count of digit 1. So, and that is what it will return. For example, for 11, it will return 2. For 1, it will only return 1. For 10, it will return 1, like that. So as you can see here again, we have a range 1 to n. We will have these positions, like, if it is a 4-digit number, we will have all these 4 positions. There will be again a concept of restricted, because if we select the first digit as the highest digit, then we have to propagate that restriction. So you will have again something like this. Position, restricted,
So how do we get the size of
and
the
then
DP array?
when I for every digit. Okay, so we will actually in a LeetCode, they don't provide that. Like, in many platforms, they will tell you exactly what is the value of n. So what I do, I look at the, like, your class definition. If it is an integer, I know its range is something like 10 to the power 9, 10 to the power 10, like whatever is the integer range. So that is what I use to find my positions, right? I add a buffer too. So
like if it is, so we are saying if it is integer, then what is the max value of integer in decimals? And then that is the number of digits I will keep.
Right. So integer is like, in Java, you have 32 bits, right? 2 to the power 32 will be what, 4 into 10 to the power 9, something like that. So yeah, then I will take 10, even 12. Sometimes I take most of the time 12 digits, because that should be very safe for me.
Okay, makes sense.
Okay. So people may have already seen this problem, so we will not spend much time. Okay. Is there anything on the chat I should look at? Hopefully not. Okay. Let's start with this since we did it. Okay. So as you remember, we just talked about, we will have position, we will have restricted, we will have sum, same story. I convert by number to a string. Then I reset my array with some -1 value to make sure that nothing is calculated yet. And then I pass this thing. Position, restricted, sum. Okay. As soon as I reach, length of this string, which is called number, I will just add the sum of digit 1, which was passed. And you will see how I am passing. That's the base case. You are very familiar with this already. A similar approach. We are going to the limit. I calculate the new restricted value, which I will propagate to the next call. This is also standard. If I equal to 1, then I will add to my sum. Hey, I have found 1 digit. So add to the sum. If I is not 1, it is anything like, 0, 2, 3, 4, 5, 6, 7, 8, 9, doesn't matter. I will just pass the same sum. Once this sum is, eventually it will get propagated, you have finished the, filling up all the positions, then your function will return that sum. And that's it. Does it make sense? Question time. Anybody has any question on this? Okay, that means everybody can solve this one. Great, we are done with one LeetCode question. Let's go to the.
I want to ask, there's like a problem in cracking the coding interview, and they count the number of 2's between 0 and n. So it's very similar to this problem, but the solution there is very different.
Oh yeah. So one thing I want to make sure, and I will explain you when I will solve this problem. see, this is easy problem. I will solve that also. I am demonstrating the use of digit DP. So sometimes you will not need it. There could be better mathematical way and other approaches to solve that. So for the same problem, you can have many solutions. So you're not supposed to just, follow one approach versus the other. But in this session, since I'm going through digit DP, I have only followed that way to solve the problem. Okay?
Okay, got it. Thank you.
Yeah, no problem. So I think it is clear to everyone, right? So we'll go to the next problem, digit count here. Digit counting range. So spend 1 to 2 minutes to understand this problem. It is very, very similar to the previous problem, and I will ask you what is the difference,
Roger,
and then how to solve it. Yeah.
sorry to interrupt you, but so if we go to the previous one, there is the last statement, and I don't know what actually it's doing. So maybe it's Pythonic, but in
it's Java.
You are returning and you are setting. I don't know what's the sequence of operation there.
Yeah, so you can just do one by one. I can just first do this DP, result equal to this value, and then I can return result. So I can exactly do the same thing, and then return in the next line.
Okay. Okay. I don't use this syntax, so yeah. I was okay. Got it. So it's setting and returning in one shot.
Yeah.
Thanks.
Yeah. Right. So take a look into this problem, find the similarity, and also try to think why this problem is different than the other one. I will be back in 1 minute.
So now we have a lower bound, right? Is that one of the differences?
Yeah, I think so. Like in earlier case, we were starting always from 0. Now here we have a range.
Okay, in earlier case, we were starting with, I think, yeah, right. Always 0 to 1. So that is one difference for sure. Yeah. It's a good observation.
The previous problem is just a special case of this problem.
Yeah, I also think it's just the special case of the previous one.
Okay, that's a good one. I think Gaurav, you want to say something on this?
So is it earlier case like in the digit was always 1, right? In this case, the digit is varying.
Yes, that is one difference. Yeah,
but that will not matter that much to us, right?
Yeah, it will not affect much.
Yeah. This is an interesting problem, very similar to the first one, but kind of extension. But it has so many different cases that it trips you. So, yep.
Yeah.
So one of the, I don't know the solution, but one of the ways we can think about is that if I just take 0 to low and then 0 to high, and I just subtract it.
Yeah.
Then we can use the same approach as before, just 2 times, instead of maybe considering low and high simultaneously. I don't know if that will reduce the complexity or increase.
No, it's a very good idea. I think it's a perfect idea I wanted to get from you guys. So it will pass all the test cases except one. And that is what Gaurav was also mentioning.
When low is equals to
And
0?
what? When?
The case when low is equals to 0?
Low equal to 0, I think not that. I think digit equal to 0.
Okay.
That,
Good.
yeah, that is a special case. So see what will happen. You guys have already figured out the answer. So suppose that was not the problem. I think last time when we were doing the sum problem, then I think Shashank asked this question that, hey, the range was 1 to n, but you are doing everything for the first position digit as 0. In the case of sum, in that problem, it was not making any difference. But here, suppose if I would say that I want to count number of zeros, for example, number of one is easy. Like, what is the number of one in this 101? I will say, okay, keep adding 2. If I say, okay, what is the number of 0 in this? No problem, 2, 1, 1, 0, 0, 3. How many zeros? No problem, 3. What will you do if I will say, what is the number of zeros in 1? You should say 0, right? But the way we are generating this is, you remember we fill 0 at all these positions.
Yeah. Okay. Got it.
So what it will do, it will count this as 3. And that was the, that is the case which will trip you. So I have chosen easier way to solve this. And the reason is exactly like I use my numbers and states to determine whether it will pass or not. So what I am choosing, that okay, other things we have already done. For example, position, everything would be there still, all the position. Restricted will continue to be there. Let's call sum will also be there. For example, sum is there. And then I am saying, is it a non-zero number or not? Tell me that too. So I have added one more dimension to my state. If it is a non-zero number, then only I will handle that case of 1, handle that case of the normal digit. Otherwise, I will say, okay, no problem. Just, handle it separately.
Non-zero. Roger, can't we combine it like we did earlier? Like when we are in the position 0, we can skip that part, skip placing 0 over there.
You can skip placing 0 over there,
and we can just move ahead with our normal approach.
Yeah, I mean, somehow you have to keep, you have to propagate that somehow. I'm not saying that it is not possible or feasible. I choose a simpler route that I will just use whether I have started creating the number or not. For example, in this case, I would say I haven't started yet creating this number. So up to this number, it is a 0, like it is not a non-zero number. But as soon as I add anything which is non-zero, after that, actually doesn't matter what I add. I can add anything. I can continue to count in the regular way. That is how I have approached it. So make sure that however you do, make sure you handle this particular case. That is what I wanted to demonstrate. I think if someone else has done that in any other way, you can go ahead and share that approach. The only reason I did it, that it didn't increase my complexity, by big margin, I will tell you. So I have a question before you ask me a question. Okay, I have a 4D DP array, but tell me, like, what is this value? 12 into 2 into 10 into 2, 120 into 4, 480, right? If I tell you, hey, I will go and create a, like, single dimensional array of value 1000, do you get worried?
No.
Ever? You don't get worried. Exactly. But just because you look at this like more dimensions, and even the bound of that, you should not just get worried actually, just because it's just 4D, right? What it does, at least it helps me with my implementation a lot. So that is why I approach that way. But yeah, feel free to pass that information somehow so that you can make the right decision with some checks. Other than that, as like you know you guys were suggesting, exactly, we will go through the same approach. We will calculate two ranges, lower range, higher range, and we will write the exact same code which we did right here. The only time I will just add this value, the sum, if I know that this is a non-zero number. If it is a non-zero number, then sum actually makes a meaning that, okay, it was a valid number. If not, then it doesn't make any sense to me. And you can see my range was also starting with 1. So I know that my low is not 0 even. It is just starting from some value which is positive. Got it? You can look at the code. I can explain the code. Everything is as usual repeating. You are so familiar with this thing. Here, this thing you are already very familiar with. How do I check whether a number is non-zero or not? What I'm saying, that if the number is already non-zero, then just take this. Maybe it's 0. If I is not equal to 0, then it is definitely a new non-zero number. You can simplify this if logic, by the way, exactly like you can simplify this, but this is how I coded when I coded. So that was the check. Suppose I was selecting 0, 0, and just now I selected a value, say 2. Then I will make sure that, hey, I have started building the number. So I will say new non-zero value is 1 because actually it's a non-zero value. Okay. And if it is a new non-zero value is 1, and is it the digit I am interested in? Because in previous problem, you were only interested in a value 1, but here your digit could be anything. You can be given 1 or 3. So that check I have just added. That's the only difference between previous problem and this problem. That, hey, I started building this number and this digit is something which the problem asks, then I will add to the sum. And otherwise, just pass the position plus 1, and then just do as we do. Just that's it. Does it make sense? Is it simple now after going through the previous problem?
Yes, I mean,
I just don't understand that non-zero part. Like, say the digit d is 0 and the number is 100. How will we be calculating the number of digits? Like, it has to be 2, right, for 100, since there are 2 zeros.
So your question is, if the number was 0, you were building number 100, right?
Yeah.
In the recursion, you are
So,
building 100.
yeah. Yeah.
So when you are building 100, you will do like this, right? 1, 0, 0, right?
Oh.
Right? You fill the first position
Yeah.
with 1, second with 0, and third with 0, right? So when you
Okay.
filled the first
I
position
get it.
with 1, you said it's a non-zero.
So you will set the non-zero. Okay.
Yeah.
Yeah.
If it was just 1 and it was a 3-digit number, you are filling 0, you are filling 0, and then you are filling 1, right?
Yeah.
So here I am not saying that it's a non-zero. I'm not saying non-zero yet. And when I'm saying it's a non-zero, then I actually just made a number 1, right? And then I would not calculate for these values. See, I will not say that 1 has 2 zeros because it came before. Make sense?
Yeah, got it.
Great. All right. So we are ready for the next problem. Done with this. You guys might have seen this problem recently. Prime number of set bits in binary representation. This question was discussed on Friday. I haven't checked the video yet, so I don't know whether you guys thought about it, this approach. But the problem is you are given a range, left and right, and you have to count number of set bits, and then you have to also check whether that is prime, that count is prime or not. For example, 6 is 110, so you have 2 set bits and 2 is prime. Okay. 7 is 3 set bit, 3 is prime. 9 has 2 set bit and prime, and 10. So these 4 cases are actually the prime. Other, like, maybe 8 will not have prime because 1 is not prime. 8 has only 1 set bit, right? So you have to just return that value. So as you can see, you have a range and you have a property like, hey, if I somehow get the sum of digit, we have just solved a couple of problems to find the sum of the digit. We learned in in decimal system, but now it is just asking in binary. But if you convert that in a binary, it's the exact same problem that, okay, I have even calculated that sum. Now, if I have calculated that sum, how long it will take you to figure out whether that is a prime or not? It's another problem whether a number is prime or not, right? So you can either write a function which checks for the prime check, or since the range is really small, like see, 10 to the power 6. 10 to the power 6 means, okay, 10 to the power 3 means 2 to the power 10. So 10 to the power 6 will mean 2 to the power 20, right? So I have 20 bits. I will pad by like maybe 2 maybe. So 22 bit I will be worried about at the most. And if I have to just say, hey, you have just range 22, then I remember the prime number for that. I don't even have to write code for that. I know 2, 3, 5, 7, 11, 13, that kind of all those values, which are within that range. I can just pre-fill it. So I don't have to calculate it all the time. And then I will just do the usual thing, which I have been doing so far.
Why is this so easy?
So there will be a different approach to do that. First of all, if you just look at this range, like 10 to the power 6, right? Forget about digit DP, then you can just go count it somehow, and then as you are going through each number, start a loop from maybe L equal to 6, maybe, for example. You can find all the digits, like set bits in that number. Suppose that value came X. And then you can check whether that is a prime or not. It should be within your range. But this problem will not work. This approach will not directly work if I make it like 10 to the power, say 18 or something. Then that will fail. So because of this small, range, it is okay. It will pass. And I'm pretty sure there could be more approaches, better solutions. So for that, maybe check Friday's session where people might have come up with a couple of approaches. Sounds good? At least you guys see the pattern, right? Why I have included this. Okay, so I would assume yes, silence is good. So now tell me, isn't it exact same thing? So, okay, I selected 21 as my position, restricted is 2, and suppose all the bits are 1. Then how many I can have the sum for that, 21 for a number at the most. So from 1 to 21, don't you guys remember the primes? I'm pretty sure all of you will already know that. So you can just pre-build it. That's not a problem. Again, what I'm doing, you have this 2 range. So we'll do L minus 1 as we learned. I will create a binary string. I will reset my DP array. I will solve the problem for just this range. Sorry, for this range in the beginning. Then I will solve the problem for the second range. And then I will return the difference. Right? So instead of like a decimal string, now you have a binary string. Nothing else had changed. Right? So you will again have the same thing here. You reached your base case. Now you will say, hey, I have a sum in my hand, and the problem asks you, okay, you can only say it is valid if it is a prime number. So I will say, okay, does my set contains that sum? If yes, then okay, we have found one valid number. Otherwise, no, it's not a valid number. If the sum was suppose 8, which is not a prime number. Then the usual thing, your restriction will only go up to 1, right? Because it's a binary number, so not up to 9. Same story. And then I will pass the sum. I should not pass the sum for 0, but I am still passing because if I add anything with 0, it will not change that value. So that's why I'm just continuing passing this thing. And then that's it to go and work. Any question on this?
So Roger, like the sum is nothing, but here you're counting the number of subnets. Yeah. Okay, got it.
Yeah. Because see, what I'm doing, this limit is nothing. It could be only up to 1.
Yeah, right.
So either 0 or 1. You can simplify. I'm writing this code because I have a pattern, so I'm just trying to apply the simpler way.
Yeah, actually,
so,
it makes sense because using the same template, it's easy to understand.
Yeah, so a lot of time I have something which you can simplify, but I kept it. Go ahead and just do this, and then. So how you are feeling about this thing? We solved 4 problems.
Roger, in this, how do you check the sum is the check where it is prime or not, that set? How did we populate the set?
So
The base condition.
Here, I since I knew my range of that it can only be up to 21. I have pre-built myself because I don't have to write code for that. But if it was a huge big number, then like you can use the sieve method or the math square root method to generate that. So you will write function to refill that.
So okay, so this is saying that in the binary representation, if I have maximum of 21 digits, then the sum of digits will be less than 21, and any of these sums, then it's a prime number, prime number of ones. So right. So 21 is the maximum number of bits binary in the binary representation of that number.
Exactly.
Okay. Yeah. Beautiful. Thanks.
Yeah. Cool. All right. So that is one approach for that. Now we'll go to a very similar problem. So this one is hard. So I would give you 1 to 2 minutes to read this, and then I will discuss it. You guys can start discussing without me, so, and then in 1 or 2 minutes I will just try.
I think this one will be maybe a second helper function we have to consult as we are generating numbers from 1 to n using the digit DP approach. At each step, whatever is the generated number, we pass it to a helper function, but that will increase the complexity by the number of bits.
But if you look at the previous prime number example, so it would be same, but only I think while calculating the limit, we just have to decide whether the limit will be 0 or 1. Maybe if the current position is 1, maybe we can pass that to the next iteration or next recursion, saying like the previous bit is 1. And it's like a flag, it's a flag, like it kinds of toggle flag. So if the previous bit is set to 1, the current limit can only be 0, right?
Okay, so the problem, you have understood the problem, right?
Yeah. I mean, there will be 2 consecutive ones.
Yeah, it should not have 2 consecutive ones. That's right. So input is 5. So which number couldn't meet the bar was number 3, because you had 2 consecutive 1. Other than that, all were okay, right?
Yeah.
That's good. And the range is n equal to 10 to the power 9, right? So if you write any code which is of the order of n, that will not pass.
Okay. Yeah.
Right? Because roughly, if you have n equal to 10 to the power 7, you can hope that that will pass in O of n. But if anything is more than 10 to the power 7, then that should give you a hint that, hey, I'm looking for a better time complexity.
Okay.
Okay.
Yeah.
Roger, can you repeat this?
Which I just said?
Yeah. I didn't understood actually this one.
So when n equal to up to 10 to the power 7, then you can hope that order of n solution will pass your online just. Especially the new machines which are being used by the online judges, that will pass. But if you start to go into the range of 10 to the power 8 and 10 to the power 9, then you better make your algorithm faster. Okay. So what is going on here? What can we do? So let's go through what is important. So you are again given a range, right? And we know that we can generate the number in binary as we did in the last time. So that's not my big problem. Suppose I have a binary number. I have to fill again some positions. And this time the selection criteria is, this is the function which I said, that it should not contain, doesn't contain consecutive 1. What does that mean? That if you have something 0, 0, 1, 0, it's fine, right? 0, 0, 1, 1 is not fine. 1, 0, 1, 0 is not fine. So basically, every time I am at a position, like suppose I am working on this guy, if I get a way to find what was the previous digit I chose, right, then I can continue building the number, right? Because if I selected 1 previously, then I should only choose 0. But if I chose 0 previously, then I can choose either 0 or I can either choose 1, right?
Yeah, we just need some flag to pass to the next recursion, right?
Exactly. So that is the idea. You can just think about that. Next time I only worry about passing what was the previous value. Maybe if previous value was 1, I know what to select in this particular position. And if I, using this way, if I keep on generating a valid number and I reach the end of my, length, I have one successful generated number, right? So what I'm proposing, same thing, position as we have been filling one by one is fine. Restricted will still be there, most likely, because we still have a range which we want to fulfill. So restricted is there. And then third value is what was my previous value I chose. So position, again, this time, you remember the number was 10 to the power 9. So 10 to the power 9 means 2 to the power 30, I guess, something like that. Yeah.
Yeah, 2 billion, right? 230.
Yeah. So I'm just selecting 33 because I know the int range is up to 32. So don't worry. 2 here. And then this previous value, this will only be 2, right? Either it can be 0 or 1.
Yeah.
So now in general, my algo would be pretty good with this state representation, right? If I can solve using these 3, and we will be, as we just talked about.
So then the gentleman who somebody proposed this while you were gone, Roger. So he was correct actually.
Oh yeah. He said like somehow he will pass a flag, right?
Yes.
Yes. Yeah, that's the right approach. I mean, that is the approach I took. You guys can find a better approach. So experiment with that. So same story. Now I have selected my DP state. Integer to binary string. I did reset this. I passed to my function position restricted previous. As long as I'm able to build that string successfully, like the number, I say, hey, I found one valid solution, right? If it's already calculated, do the usual thing. Limit calculation is the usual way. We calculate the new restricted value. The limit is again either 0 or 1. So it's not 9 because we are dealing with binary. And here is that. How do I select that what I'm saying? If position is not equal to, previous is not equal to 1. If previous is not equal to 1, then I don't care what I have. I can always include it, right? So I can always go to the next position with the new restricted value. I can use either 0 or 1. Or I is not equal to 1. If I is not equal to 1, then doesn't matter what I had previously. Even if I had 1, I am now selecting 0. So I should be safe, right? So that is how I am passing this, previous value. I'm never selecting something, never continuing with a number which has more than one consecutive one, because it will fail that check. So I'm not even going to that path. And
so Roger, just a little bit different interpretation and an or. So in that line, if previous and I you are checking, we are basically saying if previous equal to 1 and I equal to 1, then don't go. Otherwise go.
Oh yeah, that is actually right. That could be simpler. That could be simpler, I guess. If previous equal to 1. Oh, what you said, can you again say?
So I said that if previous is 1 and current is 1, then don't go. Means
Okay, yeah, right. Oh yeah, so you are passing this not here and then ending it, right?
Yeah,
Yeah,
that,
yeah, exactly. You are passing this not here and ending my or. Yeah, should be okay. All right, so we are done with this problem too. All right. Should we?
now when I think about it, key part that at least didn't click in me was that we deal with the binary representations of this. We deal with, otherwise it's naturally is okay, 1 to 5, I'll take 1, 2, 3, 4, 5. And then it blows out. But now we are dealing with the binary representation. So that is the constraint, that the number can become very big, but the binary representation will still use the same number of bits. Right? So I think that is the beauty of this approach.
Yeah. As I explained somewhere in the beginning of the session, I'm not sure whether you were here or not. See, this log square n, and that too based on based on 10 gives you a lot of flexibility. But at Coder has some problem, has few problems where they have made this constant factor really big. So, that is how they will make the problem complex. Okay, now you know how to do this. What if I make this thing bigger? Would you be able to pass it? And so that would be interesting. Should we continue with LeetCode, guys? Maybe let's continue with LeetCode then. Yeah. Okay. So this problem is numbers at most 10 given digit set. So we have a sorted set of digits. So you are given 1, 2, 3, 4. It could be anything up to 1 to 9. 0 is not included, which is good. Now we write numbers using these digits, using each digit as many times as we want. Okay. For example, if d equal to 135, we may write 13551, 135, anything we can write at any place. Okay. Return the number of positive integers that can be written using the digit of t that are less than or equal to n. Okay. For example, let's look at the example. You have been given this set. So earlier, in all my problems, most of my problems, we were using either 0 to 9 or 0 to 1, 0 to 1 in case of binary, but for decimal 0 to 9. But now they are restricting that I can only choose from this set. And my number should be, less than equal to 100, I guess. Right? Less than maybe. I don't know whether there is a equal to or not, whether it is included or not. I don't see that. Oh, actually that are less than or equal to. Yeah. So that less than or equal to. So what can you build from 1357, which is less than 100? It is 1357 and all those things. So you have to give, okay, all these are valid numbers. So when you build this number, for example, 17, somehow you should pass, hey, I found one number. For this also you will pass, hey, I found one number, and then accumulate it. But the problem is now I don't have that thing, like digit range is not 0 to 9. Okay. So yeah, let me.
So I mean, even if we go with 0 to 9, I don't know whether it works, but can we just have one condition? If the I is part of this set, if it is part, if it is not, we can just continue the loop.
Actually, that's a good idea. I don't know why I didn't think about it, but I think if I just, while generating it, if I keep checking whether this set contains this digit, then that should work actually. Yeah. So then I wrote a complex solution maybe, or maybe something which may be useful later. It's okay. But I think everybody understands the problem now already. So you are given a set. Set could be 1, 3, 5, 7. you are filling all these digits, and what you are saying that when you generate this any number, that number should be less than equal to whatever is the upper limit, right? And n equal to, I don't know what was the range, but anyway, when I'm doing digit DP, I don't worry that much normally. Okay, so suppose I don't use that approach which was just suggested earlier. How would I have generated one? I would have generated one for a 4-digit DP. Is I would have selected 0, then I would have selected 0, I would have selected 0, and then I would have selected 1, right? That was my one. In this case, suppose I want to generate a 4-digit number, but I want to end up to 4-digit number. I'm not saying like 4-digit number. I want to generate 1 from this. So I have some choices for all the positions. What I am doing, I'm saying either I will use that or I will not use it. So when I am working on, suppose, first position, I can choose to use 1, I can choose to use 3, 5, 7, or none of them. So basically, if that is empty, that means I am not filling anything here. I'm not filling anything here. I'm not filling anything here, and I'm filling 1 here to generate that. So that is, if I am filling in that way, then you know that what remains similar to the previous one. You still have the position. You have to still fill that 10 position or something. You have, okay, what can we do? Start, because whether I have started building that number or not, that is one approach I am taking. Have I started building or not? If I'm not choosing 1 in the first position, then I would say I haven't started building. But as soon as I start to build, I will say, hey, I started building something. So it is my Boolean value, which will have something like 2. Position is, as usual, we talk 10. And then restricted will work. Yes, restricted will still work because we are still within a range we are doing things. So restricted. So if I do that approach, then 10 into 2 into, in 40 states we would be done. That's the approach we are taking. You guys should continue with the approach which someone suggested and see, like, if that gives you better time complexity or very, like, different time complexity, but that shouldn't give, like, we are just doing a set lookup many times, but should be fast enough, I guess. Any question? Or actually I will show you this code, then it will make
Roger.
Yeah.
Sure. So I was thinking, like, we have 2 states now, right? Either we choose a number and we don't choose a number. So yeah. So let's say for the last case, when I started choosing 7 for the very first time, because it went till the end of the loop, means recursion. So that would be my, like, last position or first position. Like, I got confused with, means how I am reducing the position to, like, choosing and not choosing the number.
Okay. So what you are saying that, so you are generating 0, 0, 0, 7, right?
Yes. Yeah. Because I didn't choose any number till now. And in the last, last digit, I means the other recursive call where I chose the number.
Right.
So that is my first position, right? Because till now I didn't start only.
Right. If you haven't started, then you will pass on, right? You will pass on the position, right? And
yeah.
So you are passing on. And also you are also saying that, hey, suppose on the first position, for example, you didn't do that. So one more thing you have to be careful. If you didn't choose anything here, they mean same, but now your restriction will totally go off because first position you didn't select anything. So now your digit will be, you can choose anything, right, in this range.
Yeah, because I didn't start. Yeah, correct.
Yeah. So when you will pass on your restriction, you will say, hey, feel free to choose whatever you want. There is no restriction. But
Okay,
if you
so
selected
restriction will always be false for not starting.
Right. Again, this guy, again, when you are building 3-digit number, you can choose not to do anything, right?
Yeah.
So you can continue doing that. But at every position, you also go the other way. No, actually, I want to build something now, actually, 3-digit number. So you will have also the case where actually you are building something. So, you will look at code and then it will make more sense.
Okay.
But you understand that.
Yeah, I means, and another thing, like because I am introducing again one more call, so which is introducing 2 raised to power n complexity also into the code, right? Like choosing and not choosing the number.
It won't, because we have a selected set we are passing to the function. So as I explained you, we will memorize. You will not get any time more than these many states.
Okay, sure. Yeah. Got it.
Yeah, no problem. So with that, let me show you my approach, which I went ahead with. You are giving this D, which is the valid set of digit, and N is the range. So as usual, we did that, created that string version of it, reset that array, we'll run some function, will return result. As I explained, this DP array is position is 10. The start is either we started or not started yet. Restricted is either restricted or not. And this is my set of digits. They are sorted also, if you remember. So, okay, let's go to the base case. If we just reach the end, and if we actually started building something, right? We reach the end and we already started working on something, then we have a valid number, right? We generated something useful. If not, it was like, on all 4 digits we were trying to fill, we choose not to do anything. And you had this start equal to 0, for example. Then that is not a valid number, right? So we'll just return 0. All right. Same story. It's like, you're just memoizing, result equal to 0. And now we are calculating the limit. If you remember, it's still the same thing, limit equal to, if it is already restricted, then we will see, okay, on which digit we are, right? But the upper limit is not 9. Upper limit is whatever, because it's a sorted set, like sorted array list or whatever array. So I will check what is the last value. If it was 9, then it's 9. If it is 7, then it is 7. So I will just get that value as my upper limit. Right? Makes sense? A simple thing, because my upper limit should not breach that selection, basically. Now, this is what I was talking about. So I'm working on a position and I chose not to start creating number, because I want to create something smaller number. So what I'm saying, okay, go to the next position. And what is 0? 0 is, okay, we haven't started yet. What about this restriction? If I'm going to the position without selecting anything, I'm removing all the restriction. That, okay, there is no restriction. Feel free to choose whatever you can and pass this. But that is one of the choice, right? That was one of the choice, that I didn't start to build anything. But if I am planning to build something, then I already know my range. So I will go to all this possible digit I can choose. I will check, okay, what is the value on all these indices, maybe 1, 3, 5, 7, as long as I am within the limit, it makes sense. But since it is a sorted like array, if I'm breaching the limit, just break it. No need to continue. And then I will have again similar logic to pass on new restricted value using the same pattern. And then I will just pass this thing. What is 1? Yeah, this 1 signifies that, hey, I started the building a number. So if you remember here, it means not yet, I haven't started building a number, but this guy will tell I have started building a number. And you will never go for that, because now this start will never be 0, because we are passing something 1. So for those numbers, you will never go in this one. So just one extra check, and I am just, able to get that same behavior which I wanted.
So Roger, like as I asked for the like when I didn't start creating the numbers, so still I increment the position by 1, because
yeah.
That's
yeah. Why? Because see, why you will do. Suppose you want to build a two-digit number. How would you build it? You will skip the first 2 steps, right?
Yeah. So, because let's say if the size is 4, in that case,
yeah. For any 1-digit number, if the suppose it's a 4-digit number overall, max range, then first 3 times I will ignore selecting anything.
Yes. So I will still consider the position even if I select or don't select.
Yeah, because you're passing on that. Hey, for this digit, just pass on. I'm not doing anything. But yes, also make sure that no restriction. I haven't started building my digit yet. No restriction with the same valid digit. Just continue going. But then this is other case where I want to build something from that position. So that is handled here. Cool. It's after going through this session, feel free to code yourself and then look at it. I think you will understand even more. But I think it should be pretty obvious. Slowly, you will get more familiar and feel at ease with this. Should we go to the next one? We have many questions, so let's continue with the lead code. People like lead code more, so why not? Okay. Then a non-negative integer n count all numbers with unique digits x, where 0 is less than equal to x less than equal to 10 to the power n. So, okay, this is important, 10 to the power n. So that means if you have selected 2, so then that range is nothing but less than 100. So less than 100 means your overall range is 99. And in 99, you should only choose the numbers which have unique digits. So basically, you have to exclude these digits. Like 1 is not unique, 2 is not unique because they are repeating, and so on. So in 2-digit number, it looks easier, but suppose if it was a 3-digit number, then okay, let me explain here. It will make more sense. So the problem is you are given a range. I think n was 2. So n equal to 2 means my range is 10 to the power 2. So less than 100 basically. That was my range. I'm building something. All these numbers I'm building. What is my criteria? That okay, this is valid only if they don't repeat digits. How they don't repeat digits is so in this case, like if I say 1, 2, 1, we are repeating that digit. 2-digit was very simple to think, but here you can have 1 to 1. 9, 7, 6, 4, 9. It's repeating. Suppose if my range was not just 10 to the power 2, but a bigger range, like 10 to the power 6 or 7. And if I have that thing, then I have to make sure that I don't select this one. This is not a good number for my criteria. Okay. Anybody has any idea how to do that?
I'm thinking, what if you pass a set before the recursion?
Yeah.
And then once you get out of the recursion, fix it. That is, remove the digit, and then maybe use the set for comparison.
Yeah. I think passing a set, like which number we have included so far, can work, right? If while you are building, while you are selecting a digit, you can definitely say my chosen digit set. And for the next time onwards, like when you select one, you check if it is already there, just drop it, just ignore it. Don't do it. Select something which is not selected. So that is one way for sure.
I think you can, have a, let's say have a string of 10 position, right? And let's say, doesn't matter where we are, but if we see 9, we put, 9 at the proper position. And next time when we see 9 again, we say, okay, that position already have 9. Then we know that the duplicate.
Okay. Yeah. I mean, you are suggesting something a very common idea of bit mask, right? Like, because there could be only a couple of positions, right? So as soon as I select something, set a bit there, and then next time onwards, check whether that bit is already set or not. If it is set, then don't do it, right?
Yeah.
Okay. Okay, yeah. I think that should be okay, actually. That should work. So, all right. I have also used the same approach. So so question is clear, so we can directly go to the code, I think. I have one more state actually for bit mask. Let me see if we have enough information here. We'll go through it. So I have selected position. Okay. As usual, my range is, I have selected, okay, I have chosen 11 digits here. Sometimes I choose 12, but as long as, it is more than the number range, I'm safe. Your number could be up to 10 digits maybe, so it should be okay. Restricted is till 2. What is this non-zero? So, okay, I'm taking care of whether the number has, I have started building the number or not, something like that. And this is the bit mask. Okay. Bit mask is again because 11 position. So as Leon was saying, keep the set bits, right? Just, continue updating this mask. So this will be my mask here. All right. So what I'm doing with the number, suppose this number was 2, then I made it first of all 99. Math.power 10 to the power 2 minus 1. So I have a 99 here. Then I reset DP array. I solve it. And then, okay, if you look at the answer, it is also saying that 0 is also included. So don't drop 0 from that number because non-negative number contains 0 also. So I separately, handle 0. Okay. Okay, and then I have some comments. We will go through it actually. we'll go through this similar approach. Okay. Let's start with the base case. If the number generation is successful, okay, is it non-zero? If it is non-zero, then I found one valid number, no problem. If it is a zero, basically all the digits we were selecting was suppose 0, 0, 0, 0, 0, then even if I reached here, don't increase my valid solution. The regular check, here the limit is from same 0 to 9, or depending on whether it is restricted or not, we figure out what is that. All we are familiar so far. Okay, new restricted for the next time I am selecting, that is fine. Okay, what is the new non-zero value? Suppose it's the exact same way we did in the previous question. If it was a zero value, but current I is not equal to 0. Suppose now I am at position, the digit is 2, on third position I am working. So maybe previously we were going through, like, first position was 0, but the second position I am selecting a 3, then I would make sure for the next call onwards, I will say, actually whatever we are building, it's non-zero value. It's not 0 anymore. So when you are going to select candidates, this guy at least matches this criteria, that it's a valid digit, valid number. That was not tough part. Now here, what about mask? How, I think you guys might have done a little bit of a bit mask in your sessions, previous sessions, but if I am selecting any digit, like let's think about non-zero case. I will explain why this matters. I have commented it also. So suppose I am selecting 2 for the first time, then what I would say, okay, here is your new mask, set the bit position 2, right? We have a 1 and I am just left shifting 1, and then I am just ordering it there. So new mask will contain that value. If it was a 0, if it was still it's a 0 value, then I would suggest don't touch it. Don't change the bit mask, because suppose it was a 100 case, then 100 is not valid, because when you selected 1, you are in a realm where that anything you put after this is a valid number. So first selecting 0 is fine. Your bit mask would be okay. Here, when you are doing 0, right? Sorry, actually I'm doing the other way. But yeah, let's go through that. When you are doing it again, then this should not match the criteria, because remember what we said, it should contain only unique digits. 100 doesn't has unique digits. So if we already set the bit for 1, and if we again will go and set the bit for 0, that would be a problem, right? So that is why in this particular case, when we got a first 0, is it a number? Non-zero? No. Okay, don't touch the mask, because we haven't started building anything yet. Again 0, don't touch the mask, because number creation hasn't started. As soon as you have 1, yes, go and update your bit mask. Now we are going to build something. If after this something repeats, then that is wrong. But before this, if something especially 0 will only repeat before this, then you have to continue processing it, because maybe we'll start a number in future. Yeah, so that was this logic. It will be used here, actual selection, and whether the current bit is already included or not. So suppose like, here 1 0, 0th bit was already set here. Like, 0 1 0, we set the 0 bit. We again got 1 0 bit. So if you AND that, right? If you AND that, what will you get? You will get a non-zero value. Does that make sense? If any bit is repeating and you AND that with a mask, then that would be a non-zero value. So I will not actually continue processing that. I will only allow if with the current selection, we still are building up a digit which was never selected. So that is why only if that is this doesn't mean that current bit is 0. This means like whether the current bit was earlier selected or not. If the current bit was not selected, that means current bit equal to 0, then yes, it's a good candidate. Pass to the next position. We have calculated new restricted. Is it a new non-zero? It's a non-zero or not? We already verified that. And we have already found the new mask, which will say, hey, I just selected this 0, and I have updated the bit mask. So if in future, again, you see something, you just drop that. So questions. I know it's a lot of thing going on, but if you have worked with bit mask, that's the only extra logic here. That's the only thing which is changing. Questions? Don't ask why the question was medium. And you just solved a couple of harder problems. Guys, am I audible? Let me make sure, am I audible?
Oh, you are audible.
Okay.
Everyone is trying to digest this,
Oh my God. Okay.
Not
true.
Yeah.
Okay. So big picture, at least you understand the big picture, right? What we are doing. Let me explain the big picture. Then the code will make more sense. So again, right? We are building a number. What is 0 is very special. When you are selecting 0 at any point of time, you haven't yet started building the number, right? Suppose after 0, 0, 0, 1. Now when I am saying 0, 0, 0, 1, in this 0 is not repeating, if you think about it, right? Because the number hasn't started to build up yet. 0, 0, 0, 1 means actually just 1. Just because we are doing digit TP, nobody cares, right? But actually 0001 means 1, which has no repeating digit, as since 0 was in prefix. But this will have a separate problem. 1 is fine, 0 is fine, but as soon as we have another 0 here, we have to make sure that we don't select this branch actually. This is useless for given the criteria we have. So for that, we have this, every time we select something, we are going to have a mask. Sorry. So we are going to have, okay, I can't draw properly. There will be more, of course. Suppose 0th position was this. Suppose you will set a bit here 1. Suppose 1th position was here, you are setting bit 1. So next time when you are going to find a 0, if you will do an AND, the overall number would be a non-zero number for sure, because at least this digit will be non-zero, right? So if that digit is non-zero, then what we want to say that it's not a good selection. So don't proceed with this branch. Just drop it from your selection. That is the bit mask concept we are having. And why we are caring about 0 versus non-zero, that was this, the reason was this. Here 0 means different thing. here means a different thing. When a number is started, then this 0 matters. When a number is not started, actually 0 is very useful for me to build a smaller number. So I have a range of I have to fill anything up to suppose 129999. How do I build just 7? To build 7, I have to put 0 here, I have to put 0 here, I have to put here, and then I can do this 7. And when I am doing that, I have to make sure that when this was not 0, when this is 0, but actually it doesn't mean that I have started building a number, then make sure that I don't update the bit mask here, which I was just doing. Then I would not update a bit mask here 0, because if I do it, then see, as soon as I see a double 0, I will say, hey, there is a repeating 0. But if I do that, then I will drop everything. I will never be able to build anything after 0, 0, 0. Does that make sense?
Yeah.
So that's the whole idea of this code. I'm pretty sure if you look at it, I have put some comments, you would be able to figure that out.
So Roger, in this, sorry, I got a little distracted when you were talking about the mask, but the mask is basically giving the same functionality as a set. It's just more concise, right?
Exactly. Yeah.
Okay.
So yeah, you can just add your digit also. You can just add the digit, but make sure still that story will continue, that when you are having these zeros, you fix 0 before anything is started. That is a totally different thing as compared to when you have it valid 1 to 9 digit and then 0 comes, because then that makes sense. Prefix of 0 doesn't make sense, right?
Yeah. So basically, basically, whenever we pick a non-zero, at that point we are saying that I have started.
Right. Exactly. Yeah. And you remember we did actually solve some problems. That's why I brought you in this order, that you have seen the concept of non-zero earlier. So when you will watch it again, you will understand, okay, now we have handled non-zero. 0 is a special, it makes things a bit different. And then we come to this mask thing, which is very useful in this particular problem. But other than that, it's the same thing. Once you have a mask and you are making a selection, you know how to check whether a bit is set or not, right?
Yeah.
So it's not a big logic here. And if it is telling you, okay, hey, actually this selection is good, means okay, it was not selected earlier, then okay, go proceed with the position 1, new non-restricted. This value, non-zero value, would be already be 1 at this time. That okay, we have a valid number most likely, and the new mask whichever we calculated. We have been just calculating this value for the next set of selection. All right. So to make life easier, the next problem is exactly the same. So, so if it is too much overhead, you will feel a little bit relieved. It's the same problem. Look at this problem now. And can somebody tell me what we will do?
So here we will basically have the same kind of mask or set, and then we maintain a counter, and as soon as the current number that we are, or the generation, how to say it, basically the number that I'm generating at the current position, if that is there in the mask, if that then I will increment the count.
Yeah, you can. Yeah, you can keep like status whether anything is repeating or not. That you can do for sure.
Or we can subtract the like total minus number of unique possibilities.
That's a very good idea. So what Harish is saying that in the previous problem we calculated, this thing, count number with unique digits, right? If we know the total number and if I subtract from that count number with unique digit, then we will find uh, the numbers which have at least one repeated digit, right? Does that make sense?
Yeah.
Yeah. So I did exactly the same thing. So exactly same code you will see like here. All I'm doing exact same code, and this is harder just for this idea. This will become a hard problem. So n minus count numbers with unique digits, and then it is the exact same code which I have written for this. No change at all.
Okay.
Sounds good?
Yeah.
Perfect. So yeah, these problems were very similar. So I ordered in that order. Should make sense. Go take a look afterwards. And then the last LeetCode problem is this one. Find all good strings. So you are given two strings S1 and S2 of size n and the string evil. Return the number of good strings. Okay, if good string has size n, it is alphabetically greater than or equal to S1. It is alphabetically smaller than or equal to S2, and it does not contain the string evil. So okay, let me actually quickly explain on this. And I will not actually go into some of the details, but digit DP part of it I am going to explain. So suppose S1 was, I think, AA. S2 was maybe DA, something like that was there, I guess. And suppose, they are in an order for sure. So between AA to DA, what you have to do, and they have also given an evil string. So something evil was, suppose B, maybe it was a B, I guess. So while you are generating all the alphabet between AA to DA, and also they will give you a size of that, maybe only two digits. I am calling in terms of digit. The criteria is whatever you are generating. Suppose if I am generating AC doesn't contain B, then it is a valid guy. If I am generating AB, then it is not valid. If it is a BA, it's not valid. Any time it will contain B, it is not valid. And also evil will not be just one character. It could be a string like XCP, something like that, suppose. So if this the string occurs there, then it will be invalid. Okay. So quick question. Like suppose somehow you have generated a couple of characters you have written. So you have generated a new string. Suppose I have generated A, P, N, X. Suppose I have generated this. So eventually I have generated a string, right? Whether that string contains the evil, whatever was in the evil, maybe XCP or not, do you know a standard algorithm to do that?
It's a KMP algorithm, right?
Yeah, I mean, it's an efficient, if you do it in efficient way, then you can use KMP algorithm. Or there could be more algorithms which can give you a good time complexity.
Yeah, like Z and all.
Yeah, Z and all. And also we have a coming session, I think. So it's good, like, go through that and then actually, like, or go on your own, look at it. But other than that, like here we don't have the concept of 0 to 9, but we still have the concept from A to Z, right? Like my range could be like, earlier my digit was 0 to 9. If I now call a character, I will say, hey, I can generate anything from A to Z. Or I have to find a limit on that, right? Maybe I can only generate things up to P. So the same concept of restriction will apply, only thing is, okay, let me make some space, right? So you will still have that idea of position. Oh, come on. Position, restriction. What else? And then since we are matching with the ABL string, right? So you can keep a count of how much you have matched. So I have written code like this, match so far. And when I generate something and if I see, like, if the match so far was equal to the length of the ABL, then I know that this guy contains ABL string. So, I mean, and I did write this code earlier, so I don't know if I remember it well, but let's look at it. But idea is same, not a very complex idea, but yeah, it is a time-taking thing if you don't understand KMP, since I have used KMP, but feel free to use other. So LPS is basically related to KMP, where we generate longest prefix suffix. That's what I call. I don't know what does that, maybe proper suffix they call it, or what they call. Sometimes you will see it is called pi function also. But that is beyond the scope of this session. So just think there is something which will give you that check. Now you have a range, right? You had a string from S1 to S2. So what we are saying, okay, why don't you find everything from, like, from beginning, like from A to L? It's not a number. So there is no concept of zero here, right? So L means, like, from A to whatever this string is, just calculate whatever the result is there. For R, you also calculate the same thing. That's fine. And then result is R minus L. Now there is something which, if people who are watching very, like, with a keen eye, I never did anything like S1 minus 1. You remember in the ranges, every time when I was doing left side, I would say some number minus 1 and then I would calculate. But it is a string. So in a string, I don't have a way to do minus 1 or something. What was the just previous string? So for that, I mean, there is an easier way that, hey, after you are done, check whether, since I dropped this guy from my calculation, but did that guy actually was part of the solution or not? It's a very, like, simple check that whether the S1 contains ABL or not. If it contains ABL, then it was the part of the solution and I dropped it. So let me actually add it. All right, and that's it. That is the core part.
But why didn't you do it for S2 then?
For S2, so in a range, you never had a problem with the S2, right? So when you had this kind of range,
Right.
you know, from 0 to here, S2, 0 to S1, you want to calculate something between S1 minus S2, right? You can calculate things from here to here. When you are calculating from left, you don't want to, like, you know, ignore this one. So every time what we were doing, S1 minus 1, if you look at our videos or you can think about it, because I want to, like, you know, continue using that. So for digits, it's a very clear thing. But when you are dealing with a string, I don't know what could be there. It depends on the length of the string, right? Suppose S1 was AAB, right? So, so maybe, how would you say that, what was, maybe I could just do AAA, S1 minus 1.
Yeah, prior to that, okay.
Yeah, maybe I could do that, and I could just try to reuse the existing thing. But then it depends on, like, if it is a big one, then I will anyway go through that. So I just ignored that and I handled it.
Right. Because if it's AAA, then what do you do in that case, right? That is the
Yeah,
problem.
yeah. If it is AAA, then it is like, okay, what should I do? Maybe it is just AA.
Yeah,
maybe it is
sense.
just AA, or actually AZZ. I mean, I have to think about that scenario. So I just,
right.
I'm not thinking about it. Okay.
Yeah.
So with that, here is your core DP part, digit DP part. Okay. You have a string, eval, position, match so far, restricted. If match so far equal to eval.length, then we know that, hey, actually it contains eval, so it is not a valid guy. Just dump it. If not, and we have reached the string.length, so we have built something useful. Return 1. If it is part of my, like, you know, memoization, then just return it. Otherwise, do the regular stuff. We used to do int limit. Here we are doing char limit. If restricted equal to 1, then we just go to the current position. It depends on what we chose. Otherwise, the max value will be z. Result equal to 0 as usual. Exact same kind of logic here. We go through the limit. I find the new restricted. So if you are not happy about my other way of finding that, you can use this simpler way in most of the code. Maybe here I wrote in a different way. But if restricted equal to 1 and something is limit, then it's 1 or else 0. Okay, nothing interesting so far. We haven't used KMP or anything yet. But now if I'm selecting some digit, I want to make sure that how much I am matching, like, you know, with the eval, with the current selection. So this helper function will go to eval. It will take this character and it will just tell me, okay, what is the like, you know, new match so far based on my function. Okay, once you have that you have everything to pass to your helper function, string eval, position 1, new match so far, new restricted is this, and you guys are familiar about modding all those, so that is fine. After that, I have totally encapsulated this part. This is the part where you can use KMP or any other like string search algorithm. So here it is actually using that get next match and go to this after you understand how LPS table, like, you know, prefix suffix works, because it will take a long time and I haven't myself revised in a while. So I don't want to, like, you know, confuse you even more.
Yeah, no problem.
Yeah. So with that, you have solved a lot of LeetCode problems, and thanks that it is, you know, I hope like you will feel very confident again when you look at it. Like some of the questions will be like so trivial for you that you know how to go about just you have to select some criterias, right? Every time you come here, sometimes you have to pass different state. 0 was a special case, for example. In some case, we were worried about passing previous because that would help us, things like that. And I know we will be running out of time, but since I promised to my maybe some online folks who may be watching it, I will just show my code here. So if you are, if somebody is looking at it, I won't even go and explain the problem. You can go and look at, this is from educational DP contest, digit sum. This was a very nice problem actually. And when I was talking about, in the session, in the beginning, when I said like, sometimes you may get, where was that log square thing I talked about? Somewhere I talked about the complexity here. So that problem breaks that it will make it not just 18, it will make it really huge number. Then you have to become extra careful how to handle that. See what he did, the problem did, see, have you seen this kind of value? 10 to the power 10,000 or something. So if I do in my usual way, then it will fail. So I had to apply some modulo arithmetic way to find keep passing remainder, not the sum. So there is some logic around that area. So I will share this code anyway if somebody is interested.
Yeah, please.
But yeah, here is that. Here is digit parity. It is not that tough, but here the thing was that here you can pass anything. Wherever there is the question mark, you can replace it with maybe 0 to 9. But the numbers which are 2, you don't have to change anything. So while I'm building the number, there will be no meaning of restriction now, because it is either 0 to 9 or it is what it is. There is no reason for have a limit. So you can have less number of states.
What is the problem statement in this, the one that you're showing on screen?
Yeah, so here the property is that wherever you have a question mark, you can replace it with 0 to 9, right? And then you divide by 13, then there should be a remainder of 5. So you generate the digit. Now you will have a problem. It's carefully chosen this limit. If I go 10 to the power 5 is just my number of positions, right? And if I generate the number, that will be also be of 10 to the power 5 length. As soon as you reach that 10 to the power 5 into 10 to the power 5, you are reaching that 10 to the power 7 limit, which I normally take. It will not be it should not finish in time. So then I have to do something with it. So here again, when you see all these things, remainder and all those things, think about modulo arithmetic, some remainder thing. So I applied maybe something here, smartly you have to reduce your state actually. So you can see, since if I divide anything with 13, I can just contain everything between 0 to 12 actually, right? So look at it later. I'm just giving you an overview. If you look at this code and don't understand, it will make more sense. So if the current was here, then I need to apply this loop. If it was not, then I don't have to apply a loop. I already know my current number. If it was 2, then it was 2. There is no reason of limit and all. So
yeah, why there is I don't know if there is any similarity, but there is another problem on LeetCode, paint houses. If there is an existing paint color you can't choose, and you have to group them into like K neighborhoods. So that this reminded me of that. Like if it is already painted or if it is already given, that means not a question mark, then you have no option. You have to just take it. Otherwise you have the option, which is, yeah.
I have to look at it. And this problem actually, you guys have kind of solved similar problem in LeetCode. So you will understand it. Here also what they do, they are giving you a set of digits. like, so 136 is kind of set of digits. And you are saying, they are saying that you can build a 2-digit number, for example, here, but make sure that digits don't repeat. So I think, no, it's not repeat. It is basically some difference is 2 or something like that. Yeah, difference between any two adjacent digit is not more than 2. So exactly, if you keep count of the previous one, like what was the previous guy which you selected, then you can just build that number. So 1-3 is fine because the difference is still within 2 here also. But if I do 1-6, then that would be problematic. So you would not select that. So we have solved today that kind of problem. So when I will put that thing, you will understand that logic also. It's a very similar problem. Here is the core logic. That's the only part where you have previous. Make sure that previous and whatever you are selecting now, its absolute value is less than equal to 2. Then you can continue to build that. And then that's it actually. That's what I wanted to cover in DigitDB session.
Yeah.
All right. So with that, thanks for attending this session, guys. And
Thank you.
I hope that it gives you some,
Yeah.
like,
At least we have
different
some
approach.
heads up, and then we can actually go and look through all these problems again.
Yeah.
Then things
I would suggest now you know the theory, try to solve it yourself, and then look at my, my solution. If you are stuck, or even if you are not stuck, go and check like if you can make something better. If you come up with something better, then feel free to share that too. I mean, that's the whole point.
Sure.
So with that, let me stop the sharing, stop the recording.
Thank you, Roger. Very helpful.
Yeah.
Yeah.
It was a
Thank you.